Good morning, happy lunchtime, good afternoon, and good evening, everyone. My report is about constant current transformers and induction voltage regulators. Constant current transformer. The design of constant current transformer is done by General Electrical Company for series incandescent lamp for street lighting. The constant current transformer provides constant current in the variable load conditions. The secondary current becomes constant if highly inductor is connected at the secondary side, but it will decrease the power factor. The inductor should be variable type in order to provide constant current and higher power factor. Yung nasa side po is, yan po yung klase ng constant current transformer. The construction. The core length of the constant current transformer should be long and shell type. So, meron po baga tayong two types of transformer, yung core type and shell type. Dito po sa constant current transformer, ang ginagamit po natin is yung shell type. The primary winding of the constant current transformer should be stationary and secondary winding will be movable. There is an adjustable weight is attached with secondary winding. The weight of secondary winding is high as compared to adjustable weight. Working principle. The variable reactance of the secondary winding depends upon its vertical movement with respect to primary winding. When supply is given to primary winding, there is induced EMF in the secondary winding. When secondary winding is closed, the magnetic field of the secondary winding interacts with the primary winding and pushes movable secondary winding in the upward direction. The balance point between coil weight and magnetic force must be adjusted to produce desired output current. The distance between primary winding and secondary winding at full load is approximately 2 inch and the resistance of secondary winding decreases with decrease in load. It will increase the load current. The leakage reactance becomes minimum when there is minimum distance between primary and secondary winding. The constant current transformer operates as full load in this condition and produces maximum output. The efficiency and power factor will be best at 100% full load in the constant current transformer. The effect of the secondary power factor on the output current of the constant current transformer is shown in the figure. Kung makikita nyo, yung secondary power factor and yung maximum output in percentage at 100% primary is directly proportional to each other. The rating of the constant current transformer is expressed in the kilowatt rather than kilovolt ampere. Its rating is in the range of 5, 7.5, 10, 20, 30, 40 kilowatt. The secondary current rating is either 6.6 ampere or 20 ampere. Next is the application. The incandescent lamp is connected in series through constant current transformer in the street and highway lighting. If the load current increases only by 1%, it will reduce life of lamp by 20% to 25%. So, parang kapag yung load current mo is nag-increase, may negative effect siya dun sa life ng lamp. As makita mo naman, sinasabi na kapag yung load current mo nag-increase siya ng 1%, yung buhay ng ilaw mo is mababawasan siya ng from 20% to 25%. The constant current transformer provides good regulation at any load condition when the constant voltage is given to the primary winding. The constant current transformer should not overload in spite of short circuit condition. Next is the vector diagram of constant current transformer. Yung constant current transformer is under two conditions of load, the half load and full load. And kung mapapansin niyo dyan sa diagram, yung I2 is constant, is practically constant. It's either 6.6 amperes or 20 amperes. The load component IB of the primary current is constant. Change in the magnetizing current at various loads causes a slight variation in I1. Except for this, the constant current transformer operates at constant primary current and voltage, but with a variable primary power factor. Even though the secondary load may be purely resistive, the primary power factor of such a transformer is very low at light loads owing to the leakage reactance. Next is the induction voltage regulator. Induction voltage regulator is a type of an electrical machine in which the output voltage may be varied from 0 to a certain maximum value depending upon the ratio of turns in the primary and secondary windings. The primary winding is connected to the circuit, which is to be regulated, and secondary is connected in series with the circuit. Induction voltage regulator works like a rotating field transformer, and its power range is from 30 kVA to 3 MVA. There are two types of induction voltage regulators. First is the single-phase induction voltage regulator. As shown in the schematic diagram, the primary winding is connected across the single-phase supply, and the secondary is connected in series with the outgoing lines. The alternating flux is induced in the system, and when the axes of the two windings coincide, the whole of the flux of primary is linked with the secondary windings, and the maximum voltage is induced in the secondary. And when the rotor is rotated through 90 degrees, then none of the primary flux is linked with the secondary windings, and hence no flux is linked with the secondary windings. If the rotor further rotates, then the direction of the induced EMF becomes negative. Thus the regulator adds or subtracts the circuit voltage depends on the relative position of the two windings of regulators. And also, the single-phase voltage regulator does not cause any phase shift. The primary windings are placed in slats in the surface core of the laminated cylindrical core since it has to carry small currents and small conductor area. And the magnetic axis of the compensating winding is always 90 degrees away from that of the primary windings to neutralize the harmful series reactance effect of the secondary. The secondary windings connected in series with the outgoing line are housed in the stator slats due to its large conductor area. And also, single-phase induction voltage regulator, it is the unit operates as amplitude variation transformer. The secondary variable voltage depends on the angular position of the rotor with respect to the stator. A stabilizing winding is located on the rotor to reduce the leakage inductance of the secondary windings. Next is the three-phase induction voltage regulator. As shown in the schematic diagram, the three-phase induction motors have 3 primary and 3 secondary windings, and which must be spaced 120 degrees apart. The primary windings are placed in the slot of a laminated rotor core and connected across the 3-phase AC supply. The secondary windings are in slots of a laminated stator core and are connected in series with the load. The regulator does not require any primary and compensating windings because each secondary winding of the regulator is magnetically coupled to one or more primary winding of the regulator. In this regulator, the rotating magnetic field of constant magnitude is produced, due to which the voltage induced in the secondary is of constant magnitude. The phases of the regulator vary with the change in the position of the rotor on the stator. Three-phase induction voltage regulator is a rotating field transformer. The secondary voltage is constant, but it shifts by an angle variable with the angular position of the rotor. The voltage variation is obtained by adding vectorially the network voltage to the secondary shifted voltage of the regulator. So, yun lang po yung report ko. Sana naintindihan Thank you and God bless.